Respected Professor Abhirup Datta, Dean of Research and Development, Chief Guest for today's Institute Public Lecture VIMARSH, Professor Anil Bhardwaj, Professor Raghunath Sahu, Institute Chair Professor and Convener Institute Seminar and Outreach, Dr. Saurabh Das, Head Department of Astronomy, Astrophysics and Space Engineering, distinguished faculty members, dear colleagues and students. A very warm welcome to this Institute Public Lecture, VIMARSH, organized by IIT Indore, while celebrating 10 years of Department of Astronomy, Astrophysics and Space Engineering. May I humbly request Dean R&D, Professor Abhirup Datta, Professor Anil Bhardwaj, Professor Raghunath Sahu, and Dr. Saurabh Das sir to step on the stage and take the seats so that we can flag off the event. Before we proceed further, may I request respected Dean R&D sir and Professor Raghunath Sahu sir to kindly welcome today's chief guest, Professor Anil Bhardwaj, with a bouquet of flowers. I would now like to invite Professor Raghunath Sahu sir to kindly introduce the event and today's chief guest.
So, namaskar and good evening to all of you. So, as the convener of Institute Seminars and Public Outreach, I welcome all of you to the Institute Public Lecture called VIMARSH. So, this is essentially a dialogue on important topics at the boundaries of science and technology. This is a series of lectures given by eminent academicians, as you can know today, who can guide the next generation to set a milestone. Today, I am extremely happy that we have Professor Anil Bhardwaj, Director of Physical Research Laboratory, Ahmedabad, who is a renowned academician in the country. He has been instrumental in pushing the boundaries of knowledge through such public lectures by igniting young minds. I am a bit aware of because I am his Facebook friend. I am equally happy that this year is the 10th year of genesis of our astronomy, astrophysics, and space engineering department, which we all take pride in for its uniqueness in the country for training the young minds in space science and engineering. I recall my interaction with the French astronaut Michael Tognini in Switzerland. When I mentioned that I am from India, he started praising ISRO and the Indian Space Science Program. The Indian space missions and research has created an Indian identity abroad. We are known more or less for ISRO. Even if I am a high energy physicist with 20 years association with CERN, and he was giving a lecture in CERN, so he identified me as Indian and ISRO. That is the importance. So this is a special occasion. Professor Bhardwaj, who plays a leading role in these endeavors, will speak on an important topic of India, journey to moon. And I have the pleasure and privilege of introducing our esteemed speaker, Professor Bhardwaj. Professor Anil Bhardwaj, the present Director of Physical Research Laboratory in Ahmedabad. After his Masters from Lucknow University and PhD from IIT BHU, Professor Bhardwaj joined the Indian Space Research Organization, ISRO, in 1993 at Space Physics Laboratory SPL of Vikram Sarabhai Space Center VSSC, Trivandrum. where he initiated research in planetary sciences 3 decades back. He was the director of SPL VSSC during 2014 to 2017. He also worked as NASA Marshall Space Flight Center for 2 years during 2004 to 2005 as Senior Research Associate of the United States National Science Academy. His research field is planetary and space sciences and solar exploration. Experiments developed by his team have been flown on every planetary mission of India, starting from Chandrayaan-1 to Mangalayaan, Chandrayaan-2, Chandrayaan-3, Vikram lander, Pragyan rover, Aditya L1 mission. So you may be aware of all these developments. So he has published over 240 peer-reviewed papers and book chapters and supervised several PhD, MTech, MPhil, MSc, BTech students. He leads the planning of Indian planetary mission. So you might know that it has multifaceted applications, starting from fishing in the ocean to whatnot, till defense, okay, to cover only a couple of things. So Professor Bhardwaj has played leadership roles in international organizations, editor and editorial board member of reputed journals, chair of several national committees, member of governing council of a number of elite research institutions. He is the founding president of Indian Planetary Science Association and board of trustee of International Academy of Astronautics. Professor Bhardwaj, again this is to encourage the students, has received many national and international awards and honors, including the 2 most coveted science awards in India, Shanti Swarup Bhatnagar Award and Infosys Prize in Physical Sciences. He is an elected fellow of all the national science academies in India, as well as fellow of Asia Oceania Geosciences Society, a distinguished alumni award of IIT BHU, Lucknow University. ISRO honored him with their highest in-service award, the Outstanding Achievement Award in 2017. His recent international awards include 2024 Vikram Sarabhai Medal for COSFAR and 2024 Basic Sciences Section Award of the International Academy of Astronautics. He is listed in the book 100 Great IITian Dedicated to the Service of Nation, published in 2024. A chapter, A Rocket to Poke Martians, on the life and work of Professor Anil Bhardwaj, is published in children's book, They Made What, 2021. So now you can see that our today's speaker is quite eminent, and we all should get encouraged by his deliberations. And as I told, VIMARSH is a dialogue between audience and the speaker. Of course, given this big auditorium, we'll take up the questions towards the end. So you can write down the questions and we'll come back to all the questions. So with this, I invite Professor Anil Bhardwaj to deliver his.
Hello, can you hear me? Good, thank you. Thank you, Professor Raghunath Sahu, for introducing me and informing the audience that I am essentially a planetary scientist working for various planetary missions of India. And I'm going to take you to the moon, journey to the moon, and will impress upon how the country has been progressing with respect to various missions which has been undertaken and what India is planning to do in the future. इसका थोड़ा सा फ्रंट का लाइट्स ऑफ कर सकते हैं so that just front का लाइट्स ऑफ कर देंगे. So before I go into details of my talk of India going to moon or journey of India to the moon, I would like to introduce to you the the institute from which I am coming, the Physical Research Laboratory, which is called as the Cradle of Space Research in India. But in the bottom, what you're seeing here is three important elements of a mission. The launch vehicle, which you see over here, which takes the satellite into space. The satellite itself, which works in space, for example, here or here. And the big dish, which you see over here, which is required for communicating. When the spacecraft is in space, how do you communicate? You communicate using radio waves. So these are the three basic elements which is required to work and work perfectly well for the success of a mission. Now talking about PRL, that is the Physical Research Laboratory. PRL is called as the Cradle of Space Research in India, essentially because all the space research activities started in PRL under the leadership of Dr. Sarabhai, who is the founder of Physical Research Laboratory. Whether you talk about the ballooning program, the satellite program, the rocketry programs, everything started under the leadership of Dr. Sarabhai, who is standing over here. And he is none other than Professor APJ Abdul Kalam, father on the satellite, the missile man of India, who was working under Dr. Sarabhai for development of the rocketry program in the country. And if you talk about more details into this, you will see that the first rocket launch, which took place in 1963 on 21st of November from Thumba, which is a place in Trivandrum, the capital of Kerala, carried experiments which are developed in Physical Research Laboratory. So PRL has been very active in working in various sciences in terms of development of instruments. And currently PRL has 4 different campuses. The 2 campuses which you see over here and here are in Ahmedabad. And then we have a campus in Mount Abu, where we have observatories. And then a campus in Udaipur. In the middle of the lake, you see Udaipur Solar Observatory. So this is used for looking at the sun. This is used for looking at different stars and in the sky. Also, the research activities in PRL encompasses various domains, not just the planetary sciences, but also includes geosciences, astrophysics, solar physics, space astrophysics, and atomic molecular optical physics, as well as theoretical physics. So these are very wide gamut of science activities which PRL is working. And if you look at how the PRL has contributed into various domains of sciences, I will show you some of the pictures, but we'll also like to emphasize that this is the logo of PRL, and there are a lot of symbols which are sitting inside it. This is the symbol of sun, this is the symbol of earth, and then you have a big circles and arcs. Combining them together, it means that PRL research encompasses the earth, the sun, emerge in the fields and radiation, reaching from and to infinity, all that man's curiosity can intellect. So this is the essential meaning of this logo of PRL. And if you look at how PRL has actually contributed, it has contributed immensely, including the 2 chairmen of ISROs. They had done their PhDs work in PRL, Professor U.R. Rao, Professor Kasturi Rangan, Dr. Kalam, who worked in PRL. And then, of course, there are many other who are currently or have been the director of various research institutes in India. Now, let me come to the topic and talk a little bit about the solar system. And we call it as new solar system. New, why? Because Pluto is now considered as dwarf planet. So we have 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And Pluto, along with those which have been discovered beyond Pluto, Hume, Mercury, they are all planets. They are considered in the category of dwarf planets. In addition, we have objects like asteroids and comets, which are also very, very important. But if you look at the inner part of solar system, the 4 small planets compared to 4 outer planets, you will see that Earth and Venus roughly same size, Mars half, Mercury 1/3. But when you compare with that with Jupiter, Saturn, Uranus, Neptune, Earth is at number 5. But what happens when you compare with the Sun? You see where the Earth is, a small dot. And now compare On Earth, India, within India, MP, within MP, Indore, within Indore, this IIT, and then this hall, and then yourself. So how small we are compared to that of the size of the sun. So if you look at various processes which happens on the sun also, you will see that the processes on the sun are huge in size. For example, these are called sunspots on the sun, and they are compared to that of the Earth and Jupiter. You can see the processes which is happening on the sun is much huge. And now you compare this with the size of various moons in the solar system. The biggest is Ganymede, the second is Titan. Mercury is smaller than the satellite of Jupiter and Saturn. And whereas Earth moon, it is at number 5. So Earth's moon is at number 5 in terms of the size of the natural satellites of different planets. So we will concentrate now on moon and we will take a journey to the moon. But before that, let me thank all the lunatics, not the lunatics, right? Because when we talk about various missions, there are very large number of people who actually contribute to this, which includes the rockets, the satellite, the ground support, and then of course the scientists who work for bringing out science. Now let us go to the journey to the moon. How did we start? We start with the Chandrayaan-1 mission in 2008, followed by Chandrayaan-2 mission in 2019, and then of course the most celebrated Chandrayaan-3 mission in 2023. And I will give you a brief about what has happened in all these 3 missions, and then we'll talk about what we plan to do in the future. So when we talk about the Chandrayaan-1 mission, which happened in October of 2028, we had the launch, carrying 11 experiments on board, truly international, 10 different countries participating. And if you look at this busy satellite, and you can see it much better on the next slide, where you can see various experiments sitting on different sides of the spacecraft. And on the top, the gray box you are seeing is the Moon Impact Probe, which was essentially released after we reached 100 kilometer circular polar orbit and landed onto the lunar surface on 14th of November 2008, making MIP, that is the Moon Impact Probe, the first man-made object from India landing onto the lunar surface. It has provided us a lot of good science, the MIP, which has landed on the surface. But when you talk about the science results which has come out from the Chandrayaan-1 mission, there are more than 250 scientific publications. And the most important is discovery of water. So it is the Chandrayaan-1 mission which has discovered water on the moon. Till that time, we are thinking the moon is bone dry, but the Chandrayaan-1 mission is told no, water exists on the moon, it is there on the surface, it is there beneath the surface, and it is there above the surface. In addition, there are many other science results which has come out, including the various discovery of new minerals, talking about discovery of mini magnetospheres, talking about how moon got formed, that is the lunar magma hypothesis, and of course the interaction of the solar wind with the moon. There are various papers which have been published. Some of them has made the cover pages of various journals. So these are very important scientific journals whose cover pages are made the science results from Chandrayaan-1. Now talking about SARA, where I was directly involved as the PI of the instrument on the Chandrayaan-1, how does the moon goes around the Earth? This is Earth, right? And this is the orbit of the moon going around the Earth. So around 2/3 of its orbit, the moon is in the pure solar wind. Solar wind is a wind which is coming from the sun continuously 24/7, which is largely plasma, protons, and few percent of WN as helium, coming with a supersonic speed of about 400 kilometers per second. Since moon doesn't have atmosphere, it comes and hits the lunar surface. And it is assumed that everything gets absorbed. Now this picture, which is happening every 28 days, right? Because moon takes 28 days to go around the earth, right? Isn't it? भाई आप लोग interact नहीं करोगे तो फिर मजा नहीं आएगा. So you have to keep responding, okay? Now this picture of understanding of how the solar wind interacts with the moon will get simplified or will get complicated. We'll see the story. But let me first show you how the lunar surface looks like. Let me see if it works here. Oops. Oops. Good. So this is how the surface of the moon looks like from the Chandrayaan-1 mission itself, which shows the surface of the moon, and all these are craters. Small white patches which you are seeing, they are all craters of different dimensions. So moon par bahut dabbe hai. Moon is full of craters of different dimensions, from meters to centimeters to kilometers to 10 to 100 to thousands of kilometers. And you will see all these different kind of colorations. So never compare the moon to any Chandramukhis, okay? Because it is full of spots. Now this lunar surface is impacted by solar wind, which is plasma, coming with a speed of 400 km per second. That is something like 1 keV protons coming and hitting the lunar surface. So what we were earlier knowing, that this is how it looks like. The solar wind comes and gets absorbed on lunar surface, and you have a wake, very huge in dimensions, several lunar radii. This has now been converted to this complex picture which you are seeing over here, coming out from the Chandrayaan-1 mission, telling that everything is not absorbed. A significant amount of solar wind protons are reflected back as neutral hydrogen, not as protons. And about 1 in 5 particles are coming back. And that's why this made a ESA press release telling that hydrogen offers a new way to study the moon. We also discovered protons on the night side in an orbit. Every orbit we are seeing ions on the night side, 100 kilometer orbits. So there are a lot of new science which has come out. I will skip some of this because it may not be very interesting for the kids. And we will jump to one of the very important results which we did using the special experiment using our Indian Deep Space Network, is to study whether moon has an ionosphere. And we found it does have, with the plasma densities of about few hundred particles per cc. And I will come back to this later on. Now let us talk about the Chandrayaan-2 mission. The Chandrayaan-2 mission was a much more complex mission than Chandrayaan-1. Why? Because in addition to orbiter, which was there in Chandrayaan-1, we had a Vikram lander and a Pragyan rover which was sitting inside. And we had the fantastic launch. We went into orbit around Earth, then into orbit around the moon. And then we started landing onto lunar surface on 7th September 2019, early morning. And we all know what happened, right? We could not land well. But the orbiter of the Chandrayaan-2 is still in orbit around the moon, still working for last 6.5 years, providing us excellent quality of data, including an instrument called OHRC, which you see over here. And this instrument has the highest resolution ever available onto the moon to give you fine features on the surface. This provides you a resolution of almost like 1 feet from 100 kilometers. So you can see much very clear. And this is the one which was used for deciding the Chandrayaan-3 landing site. So there are a lot of details which has come out from this, talking about boulders and craters in permanently shadowed regions. I will talk about this later. There is a crater on the surface of the moon named after Dr. Vikram Sarabhai, called the Sarabhai crater, which is quite big in size. If you have a small telescope, you can actually see it from the Earth. The dual frequency radio science experiment has provided information from above the surface or on the surface to few meters beneath the surface. So you can know what is present beneath the surface also. And there are, of course, what you call ice deposits, which has now been known to be there in the polar regions, particularly talking about how the ice is getting formed and what are the processes in which the ice gets formed in the polar regions. In addition to this, there are also information which has come out from Chandrayaan-1 data sets talking about volatiles, because volatiles is the one which keeps us interest on the moon to understand, because water is also one of the volatiles. It has also given us a lot of information on elemental composition distributions across the moon. For example, sodium, how the sodium is distributed on the surface of the moon, hydration, that is water distributions, and of course talking about argon distribution in the atmosphere of the moon, as well as elemental composition. I'll come to that later also. Also, we have seen space weather on the moon. And this happened in May 2024 when we have a big solar flare and CME's ejections. It did show impact on the moon by enhancing the pressures, which are seen in this curve over here, and that clearly shows the linkage of activities happening in the sun with respect to that on the moon. We also have a solar X-ray monitor, which is developed in PRL, and this is working very well for the last 7 years, providing us how the solar activity is varying in the extreme ultraviolet to X-ray regime, which shows that we are seeing now a solar maxima and declining phase of the solar maxima. Now let me talk about the Chandrayaan-3 mission, which is of course the most celebrated missions, and we know that Chandrayaan-3 did not require the orbiter because Chandrayaan-2 orbiter was already in orbit. So we said we need only a propulsion module. And propulsion module just to carry the lander, and inside the lander is the rover. So this is the Vikram lander sitting on the top on the propulsion module in clean room in Bangalore. And this is in Sriharikota, where you are seeing this heat shield on the sides of this Vikram lander sitting on the top of the propulsion module. You will see that we have 3 experiments on the lander and 2 experiments on the rover. So we are having experiments both on the lander and the rover to do science on the moon. And I will come about some of the science results about what has come out. But APXS talks about elemental composition. This was developed in PRL, whereas LIPS was also talking about what kind of minerals are present and breaking down to see what kind of elements are present on the lunar surface. Both of them were sitting on the rover, which is moving on the lunar surface. And on the lander, we have a seismometer, which talks about seismic activity on the lunar surface. Chaste, which was more or less like understanding the temperature profiles beneath the surface up to a depth of 10 centimeter. And then we have a Langmuir probe, which was deployed on very close to lunar surface on the lander to look at the plasma environment very close to the landing site. Oops. So this is the Sriharikota. You are seeing the launch pad over here. This is the GSLV Mark III. And on the top you see over here, within the heat shield is the Chandrayaan-3 Vikram lander. We had the fantastic launch on the middle of the day on 14th of July. Would you like to see the launch? Yes? Okay, let me see it works. Okay, good.
6, 5, 4, 3, 2,
You will see the ignition here.
0,
Ignited. Mark III has started.
plus 5 seconds.
Liftoff normal.
Here we have a majestic liftoff of LVM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का यह भीमकाय रॉकेट आसमान को चीरते हुए अपनी भयानक दहाड़ से चारों ओर कंपन उत्पन्न कर रहा है। इसे हम यहाँ महसूस कर सकते हैं।
So this was the
ये
launch.
दहाड़ है जो वैज्ञानिकों को रोमांचित करती है। LVM-3 के उत्थापन के साथ ही हमारे अंतरिक्ष यान चंद्रयान-3 की चंद्रमा की यात्रा प्रारंभ हो चुकी है।
As the rocket is soaring through the clear skies, every second moving closer to the accomplishment of the most important milestone in its mission to moon.
So this was the launch. We are all sitting about 5 kilometers on the launch pad, really feeling the thunder as well as vibrations when the launch was going up. Nobody is allowed at near the launch pad. But those who are interested to watch the launch can go there and actually watch the launch from a pavilion which is made there in Sriharikota. So after the launch, we went into orbit around the Earth like the Chandrayaan-2, then got inserted into lunar orbit, in elliptical orbit first, then came down to 100 kilometers circular, and then finally came down by 100 by 30 kilometers. And from there, we actually started descending onto the lunar surface. So this was a D-Day. I don't know how many of you watched live the Chandrayaan-3 landing. How many of you watched live? Still few of you could not watch live, right? You want to see the live landing? Yes? Okay, let us see.
Sensors that are updating at this point.
This is the very
are
last
providing
leg, okay?
confirmation of the safety of the landing site.
You can see me over here.
The retargeting is going on. And
You can
this
see
is a very good
then
signature
current chairman
for the
sitting
lander.
over here. Prime
अभी आप
Minister
ये
was
देख
there
सकते हैं
in
कि
South Africa
लैंडर
watching
की
live.
ऊंचाई लगभग 65 मीटर के आसपास
You see the
रखी हुई
distance,
है।
65 meters. We started from 30 kilometers, okay? So we started like this, and then started
Currently,
coming
only
like this.
2 engines
Then we
are
become
now
almost
being
vertical
fired,
when we are coming close.
and we are
And then we
hovering
hover
at
and see around
zero
where to land,
velocity, vertical
and then finally
and
land.
horizontal.
So
We
it is
are- we were
totally
hovering and now we
autonomous
are
landing.
Approaching
No
the
command
moon's
control.
surface.
धीरे-धीरे लैंडर की वेग
So we are seeing all live data which is coming to us
50 मीटर
in the mission control,
कम आ चुके हैं।
seeing what is happening. The distance is reducing, is 35 meters, and
We
our
can
heartbeats
see
are
the
going up.
Honorable Prime Minister, Shri Narendra Modi ji, who is here to encourage us. And
So 2 engines
he is
are firing. There were
critically
5 of
looking
them
at the visuals.
in the last leg of the mission. We are just approaching, you will see the landing, final touchdown.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
People are applauding. Let us all wait to hear from the Secretary, Department of Space and Chairman ISRO, Shri S. Somnath.
And the Prime Minister was waving the flag of India,
सेफली और सॉफ्टली
celebrating the
चंद्रमा की
landing.
सतह पे लैंड हो चुका है। ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के।
So Chanda Mama apne ghar ke ho gaye. We have landed successfully. And therefore, everybody was over the moon, and I was also feeling over the moon, so I took the selfie with this small module or a sample kept in the mission control. But then, how was the world celebrating? I'll show you some of the news clippings.
India has done it. It has become now the 4th country to land a spacecraft on the moon after the US and China and the former Soviet Union. Just moments ago, we're talking just a...
India has made space history, becoming the first nation to soft land a spacecraft on the moon's south pole. India has become the first nation to successfully land a spacecraft near the south pole of the moon. The country's PM Narendra Modi has praised the achievement, saying that the mission success belongs to all of humanity.
The spacecraft Chandrayaan-3 is attempting to become the first to land on the moon's south pole.
India is the first country in the world to land a spacecraft near the moon's south pole, a moment of history for the country. It was a tense final 6 minutes as it descended onto the lunar surface. Let's show you the moment. First of all, let's take...
This agency is celebrating the successful moon landing of its Chandrayaan-3 spacecraft.
Okay, now India's lunar probe Chandrayaan-3 has landed on the moon's south pole. India is the first country to touch down on this part of the moon, which is believed to hold pockets.
We begin with some historic news. India has become the first country in the world to successfully land a craft near the moon's south pole. Prime Minister Narendra Modi was watching the mission from South Africa and congratulated the team back home. Let's take a closer look at one.
So the whole world was actually celebrating India's success because India is the first country in the world to reach near the South Pole and successfully landing a spacecraft. But then, we were all busy after this celebration to take out the Pragyan rover, which is sitting inside the lander. And we had done several tests of how this will be deployed onto the moon. But now we have to actually do this, right, on the surface of the moon. So how we did it? Let us see. you will see first time the ramp deployment, which has happened on the surface of the moon for the Pragyan rover to come out. You see the legs, the ramp is getting deployed, and this is the first glimpses of the Pragyan rover, which are sitting inside the lander. Now solar panels will be up so that it can generate the power. And then we kept it for some time, for about a couple of hours, for the power to be generated. And we found that everything looks fine once the power was generated. Now the baby has to roll onto lunar surface. So you will see how the baby started rolling. So this was the first step from the Pragyan rover on the lunar surface. We are all very delighted. But did you see one thing? There was a crater in the front. And we are all holding our breath. And I was seeing it live when the video was coming, that we are seeing the first crater right in the front. Then there are two eyes or cameras in the front, which told us that crater is very small, no issues, you can pass through. And therefore, this crater was passed through. And the rover has passed. So this is the first hurdle, the first crater, no issues, we continued to work. But then we found a big crater. And then we said, oh boy, ye bahut bada hai bhai, ye to nahi hoga. So we rolled back. You see here the wheels forming the imprints on the lunar surface and how they were going around. We took the selfie, that is the Pragyan, took the selfie of the Bade Bhai Vikram. So this is the selfie taken of the Vikram lander. And this was also very important for us to know where we landed, how was the surface, because a lot of science issues which are coming out got resolved once we came to know where we have actually landed. And the three instruments on the lander, the ILSA, that is a seismometer, the Chaste, which has gone inside the lunar surface up to a depth of 10 centimeter, and the Ramba LP. You see the shadow of this. All three were deployed very well, and that shows that, yes, whatever we have planned to do science has been achieved in terms of putting them into job for working for next 10 to 12 days. Because this whole mission was for only one lunar day, which is 14th Earth days. And this point which we landed now is called Shiv Shakti, right? And now 23rd of August is celebrated as, let me show you if it works here. No, it doesn't work. Chalega bhai? No? Let me see. So you see a plate moving there in this picture. It's going back. So it used to be in the stout condition. It will become vertical, very close to the surface, make measurements, and then move back, and then the rover will move. So every time the rover is stopping, this kind of mechanical movement was happening on the lunar surface. It happened 30 times. And every time we are making measurements. So you see here the locations where the measurements are made. And this has given us first information about the elements present onto the lunar surface. So you see here what elements, you name it, magnesium, sodium, aluminum, silicon, sulfur, potassium, calcium, titanium, chromium, manganese, iron, nickel, zinc. So all major and minor elements known were detected by these instruments. But then it found that we are seeing higher abundance of magnesium than it should have been at this landing site, which in turn suggests that extra magnesium has come from somewhere else and sitting on this landing site where we have landed, and that we suggested it has come from the South Pole Aitken Basin, which is the biggest basin in the whole solar system, sitting on the south pole of the moon, And because of this basin getting formed almost like 4 billion years back, this magnesium which is sitting inside the lunar, inside the moon, has come out and has been sitting on the landing site. So this was the hypothesis which was giving this Nature paper, which later on got proved when we started looking at volatiles into lunar surface to understand what happens to sodium, potassium, and sulfur. We found that sulfur abundance is much higher than sodium or potassium, which in fact corroborates what we have told earlier, that this is only possible when deeper material from the moon has come and landed onto the lunar surface. We also are now finding recent boulder falls, which in turn suggests that moon is not geological dead. There's a lot of activities is happening on the moon, including more recent volcanic activities in the recent past in geological time scale of 10 to 100 million years. So what we have found that the landing site where we have landed is actually a big crater, which is buried now, so we can't see that. That means the material has come and filled the craters. We also found there's a lot of tectonic activities, different features, both in terms of geomorphological and geophysical processes, which is giving us information about the landing site in a bigger context. And then we found clear evidence of water presence, magnesium and sulfur being higher, and also that this landing site is almost like 3.7, 3.8 billion year old. That means this was a very old terrain where we have landed onto lunar surface. I will skip this except to tell you that now we know what weight percent of each element in form of oxide is present there, because moon has very large amount of elements, but all in oxide form, nothing in pure form. And therefore, you will see all this in oxide, silicon, titanium, aluminum, iron, magnesium, sodium, potassium, all are in oxide forms. I will skip this. What next? What you are planning to do next? We are planning to have Chandrayaan 4 mission, which is going to be a sample return mission. Sample return means, so far we have orbited, we have landed, we have moved onto lunar surface, but now we want to bring back the sample from the moon to the earth to do much deeper analysis of what is present there. And for that, we are planning for a mission called Chandrayaan 4, which will be a very, very complex mission, because you see over here, there will be 2 launches within a period of a month or so, and they will be docking and undocking in space. Docking means 2 spacecraft joining together in space and then separating out. So there will be docking happening in the orbit around the moon. There is docking happening in the orbit around the earth for the success of this mission. Module has to go from earth to earth orbit, from earth orbit to moon orbit, from moon orbit to the moon surface, from moon surface back to the moon's orbit, from moon's orbit back to the earth's orbit, from earth's orbit back to the surface. So this whole process is quite complex because different spacecraft have to talk to each other and meet each other and work in cohesion. And therefore, some of you may have heard about the mission called SpaceX, which country has taken last year beginning, where 2 different spacecraft in space were docked to each other and then undocked. That means 2 spacecraft moving at a speed of about 28,000 kilometers per second, talking to each other and then coming closer and going together and then separating it out. This is a technology in itself because no other country will give you that technology. You have to develop within the country. And that's why this mission is going to be a very complex mission, because so many steps are there for the complete success of this mission. But the essence is to get back the material from the lunar surface back to the Earth. The next mission we are talking about is Chandrayaan 5, Lunar Polar Exploration, LUPEX mission. This is an Indo-Japan collaboration, or ISRO-JAXA collaboration, where the focus is to go into the polar regions, poles of the moon, and particularly going into the permanently shadowed region. Permanently shadowed regions means, you see over here, this region, it is completely dark. It is dark all the time. and therefore it doesn't see the photons. If it is not seeing the photons, the temperature will keep going down and down and down. That means these are like a deep freeze. Temperature go down to 20, 30, 50 kelvins. And therefore, if there is any volatile which goes into these regions, it will completely sit for ages. Unless until something excites it, it will not come out. And therefore, the idea is what is sitting there. We have seen through some remote sensing that it is expected water sits there in addition to other volatiles. But then there has to be measurements by going. And that's why this mission is planned. This is a bilateral between India and Japan, or ISRO and JAXA, where ISRO is providing the lander and Japan is providing the rover, which will go inside these craters, black areas which are seeing, and probing it what is there inside. But this is a very challenging mission. Why? Because you have to sit at a landing site which is sunlit. Because you have to generate power using solar panels. That means sunlight has to be there in the polar regions. And then the rover also has to be charged by the sunlight. Then rover goes inside the polar regions, explore, come back, get charged, go into another nearby dark regions, explore, come back. And that's how the mission is planned. The lifetime of this mission is about 3 months, over which few of these dark regions of the moon in the poles will be explored. But why moon has this dark patches, which you call as permanently shadowed region, and not Earth? Because moon is almost vertical. And this is how it goes around the Earth. Whereas Earth is tilted, 23.5 degrees, right? And this is how it is going around the sun. So Earth and moon have a very different tilt, and because of which, in the case of moon, if there are deep craters both on the poles, north and south, they will never see the sunlight because sunlight moves in straight line. Oops. So this is a very important mission for the entire lunar community, because this is going to be the first time that we'll come to know what is there in the permanently shadowed regions. And there's a lot of work which has been carried out to understand where we'll do the landing near the polar regions, where we'll see the sunlight for at least 6 months for charging of the lander and the rover. But then there should be a permanently shadowed regions in the nearby. So, summarizing what we plan to do and what we have done. In 2008-9, we had the Chandrayaan-1 mission, the orbiter, which discovered water on the moon. We also had a moon impact probe, which has already landed in 2008 on the lunar surface, implanting the Indian flag. In 2019, we had the Chandrayaan-2 mission. The orbiter is still working around the moon. The Chandrayaan-3, we had the Vikram lander and the Pragyan rover, which moved onto lunar surface, provided excellent quality of data. Next, we are working on Chandrayaan-4 mission, which is going to be a sample return mission. So we are going to bring back the sample from the moon. Chandrayaan-5 is an ISRO JAXA mission where we are planning to go into the polar regions of the moon and explore what is sitting there. Both of these missions are extremely new, both for India and Japan and for the whole world. But beyond that, we are also talking about Chandrayaan-6, Chandrayaan-7, Chandrayaan-8, and then crewed mission. Till 2040, when we are talking about Indian landing on the moon. So this is a long roadmap which is laid, and there are several milestones which has to be covered to achieve the human landing or Gaganyatri landing onto the lunar surface. But after that, once we have done that, we are talking about the Bharatiya Chand Dwar. Dwar means gate, and then Bharatiya Chand Nivas means people staying there. So this is a far-fetched long-term plan for the country, where we are not only just going and exploring, but also started talking about staying over there. And once we talk about staying over there are many steps. If you look at this, the Chandrayaan-7 is a lunar nav cam. Now, everybody has a mobile, right, in their pockets. and you have GPS over here. What about GPS on the moon? Because once you land and you want to communicate and you want to know where is the other person who has also landed on the moon, how do you know? You need a GPS on the moon. And this is what the navigation and control systems or navigation communication system is. So this is the kind of activities is going around the world where we're talking about landing on the lunar surface, but not only landing, communicating. How do you communicate? You communicate using radio waves, and that is what will be done. But then, are you carrying everything from Earth to moon for sustaining? No. We have to do sustainability on the moon. That means use the material which is available on the moon to sustain your life, and that is what is done in ISRU, in situ resource utilization. That means you utilize the material which is available on the surface of the moon for your own living. That's why you can sustain. Otherwise, if you keep carrying everything from Earth to moon, it will be very costly and very difficult to sustain in a long run. In addition to this, you can also use moon as a base for future exploration, going to Venus or Mars or other part of the solar system. So, long run, the plan is to not just explore the moon, but actually to start staying over the moon. All the science data is there in this. Those who are interested can look at this website. So with this, I would like to, I will skip this. So I would like to thank you all for listening patiently. But so the future is for all the kids who are sitting over here. Some of you may be actually staying there on the moon. Some of you may be going to the moon and coming back. But probably your kids may be continuously staying and you may go and visit them. Right? So there's a lot of scope for the youngsters who are sitting in this audience to start thinking about how you can actually contribute and understand in this exciting journey of exploration of the solar system, but more particularly understanding the moon and then exploring it in much more detail so that we plan to stay and explore further. Thank you very much. So if you wish to have some questions from the audience. By the way, I am also very active in social media. You can see my coordinates over here.
Thank you very much, sir. Thank you very much, sir, for sharing your knowledge with us. Now we will open the floor for question and answer. May I kindly request the audience to keep their question brief and relevant? You may ask a question. Any question from your side?
माइक दे दीजिए इधर.
Sir, my name is Saududdin Khan and I am from mechanical engineering. So my question is that why we publicly say that we found water on the moon and it's better to keep it secret and use it and strategize it for future human settlements?
See, science is for humanity. And whatever you found, we have to make whole world aware about it and also to make use of it. So whenever we are doing science, it is not for the personal use. It is for the humanity.
So in this, we can doing the same we are doing on Earth with.
इसको ऑफ कर दीजिए.
So on the moon, same thing will happen as we are fighting for oil.
Let us see what happens, but always what India has been for that we make the things aware to the whole world. Whole world is one, right? And that is how the concept is. In the case of science, when you discover certain things, you make it aware. How do you make it aware? You write a paper and then publish it, right? So that means the science which you are doing has to be checked by others. And then only it is acclaimed that yes, it has value, it is something new, right? And once it is new, then you feel happy. But all discoveries are like this, that you first understand it, write a paper on it, publish it in international journals, others will look at it, and then only it will be called as a discovery.
Good evening, sir. My name is Rishika Sharma, and I want to ask a question that USA ने मून पे लैंडिंग कितनी पहले कर ली थी, बाकी हम लोग अब पहुंच रहे हैं 2014 में पहुंचने की कोशिश कर रहे हैं, तो वो फेक था क्या? फेक था क्या?
नहीं, nothing was fake.
तो हम इतने पीछे क्यों हैं?
हम पीछे नहीं हैं, अभी हम आगे निकल रहे हैं. We have come equal to all the countries in the world. See, Apollo landing happened in 1969, right?
Right.
Isn't it? Still, we were all thinking till now that moon is bone dry. There is no water on the moon. So what is lacking? In spite of human landing, we are still thinking pani nahi hai moon pe. But now we know water exists on the moon.
Yes.
So it is not that you land at a particular place at a particular point of time that you can discover everything or you can know everything. There is still much more to be learned about the moon. When we landed at this point, which is now called Shiv Shakti, we found something very different at this landing site, which is not known, right?
Right.
So it has nothing to do with who is ahead or who is behind or who has done it before, right? It is a matter of when you do it with full conviction and bring out something new. Nobody has landed in the polar region. Why? It was difficult. Nobody has tried doing it. India said, no, we'll go for the most difficult one, right? That's how it is. People are still thinking about asking questions. I will give you some incentives if you ask questions.
Hello, sir. So my name is Nihal. So I wanted to ask, like, when we talk about like going to the moon, like sending crewed mission to the moon, do we think like at the present time, like we have the resources as ISRO, we have the funding and like resources to like achieve that?
Yes. When we are talking about going to the moon and landing of humans on the moon, not only humans, Indians on the moon, yes.
Yes.
That's why this is a long-term mission. It doesn't take that you decide and tomorrow you do it. There's a lot of technologies which has to be developed for it, for having this kind of missions. And therefore, you have to plan it for next 15, 20, 30 years down the line, and then start developing technologies for that. Sample return mission is one of them, which is again a technological development, that you land on the lunar surface, bring something back. Because humans have to be brought back also, right, initially. It is not one-way ticket, na? Jaake chhod diya, jao, roab. No, right? We have to bring it back. And we have to do it multiple times. Then only we can think about people staying there on the moon. So there are a lot of technological challenges which comes and a lot of new technologies which has to be developed. And therefore, it's a long-term program.
Thank you, sir.
Hello, sir. This is Chakrapani from BTech second year, Space Engineering Department. Sir, I just want to know a few suggestions from you. if someone like me are really interested to work on the upcoming Chandrayaan missions, like what will be your suggestions? It is my childhood dream.
You can start working now itself and start contributing into the mission programming, planning, or looking at small activities which is linked to these missions. Because there will be series of missions, as I told you. Chandrayaan 4, 5, 6, 7, 8, 9, 10. You can imagine the amount of work which is required to conduct this kind of missions. As I told right in the beginning, there are thousands of scientists and engineers working together for realizing a single mission. So people from all backgrounds of science and technology and also engineering. And now we are talking about human in space program. Human going means we need people who are working in medical science, people who are working in biological science, people who are working in food technologies. Because human going to up in space, they will eat food, right? So you have to carry food for their survival, unless until they start cooking on the moon, isn't it? So people from all backgrounds, of any background, is actually required for space exploration. Only thing is you have to choose what you want to contribute. That is in your hand. Okay? You can talk to me later on it.
Thank you, sir. Thanks.
Hello, sir. So, thank you so much for such an insightful presentation. So, first of all, you have mentioned various sensors that is operating on the lunar surface. So, can you, in Earth also, we do have certain sensors, like we have SAR and other kind of meters. So, are there any difference in type of data that we are getting at the places out of Earth, like in moon? Is there any difference operating those sensors in the moon and Earth?
Yeah, good question. So actually, sensors are similar compared to what we are using on the Earth. Like you talk about SAR, that is synthetic aperture radar, for example, right? But the operating conditions are different. Here we are looking at from an orbit of 500 kilometer or 1,000 kilometer, looking on the Earth's surface, and looking using the SAR at different frequencies. If you talk about moon doesn't have an atmosphere, right? So you are straight away looking at the surface of the moon or beneath the surface. In the case of Earth, depending on frequency, you can have contribution from the atmosphere, right? Which is good if you are an atmosphere scientist, but bad if you are a geoscientist, because you don't need interferences coming from the atmosphere. So conditions are different, but the principle or the technique is same.
गुड इवनिंग सर। सर मेरा क्वेश्चन है कि वर्ल्ड की सारी कंट्री जो है वो इस बात को पॉइंट कर रही थी कि इंडिया एकमात्र ऐसी कंट्री है जिसने साउथ पोल पे सैटेलाइट लॉन्च किया है। अगर सर ये तो बहुत गर्व की बात है कि इंडिया ने ऐसा ऐसी पहली कंट्री बनी है, पर सर वाकई इतना अगर डिफिकल्ट है तो क्यों है? साउथ पोल में ऐसा क्या है?
साउथ पोल में ऐसा क्या है? ओके, अगर आप मून को देखेंगे तो लैंडिंग जितनी भी अभी तक हुई हैं वो सब मोस्टली इक्वेटोरियल रीजन में हुई हैं। इक्वेटोरियल रीजन मीन्स समथिंग लाइक 40-50 डिग्री फ्रॉम द इक्वेटर ऑन द नॉर्थ और साउथ। ओके, फार साइड लैंडिंग एकमात्र हुई है जो कि चंगे मिशन ने किया है चाइना ने रिसेंटली। टेक्नोलॉजिकली चैलेंजिंग इसलिए होता है कि यू फाइंड इट डिफिकल्ट फॉर कम्युनिकेशन। Number 2, the solar radiation which is coming is reduced because it is oblique to the surface. So the amount of sunlight which is reaching at the landing site is reduced, right? When we landed on the Shiv Shakti point with the Chandrayaan 3, we landed on the second day of the day at that landing site. What does it mean? It means somewhere around 6:37 a.m. local time we landed, because we know it is only 14 days, sunlight will be there. So in local time when you convert, it is something like 7 a.m. to 5 p.m. We will have sunlight. But the amount of sunlight is reduced because it is oblique. बॉल है ना, तो अगर आप यहाँ पे बैठेंगे बॉल के ऊपर तो आपको कम सनलाइट मिलेगा। यहाँ पे बैठेंगे सबसे ज़्यादा सनलाइट मिलेगा, राइट? सो अमाउंट ऑफ सनलाइट गेट रिड्यूस, नंबर वन. नंबर टू, as you see from the earth and the moon is rotating, right? We see only the one side of the moon, right? Isn't it? पीछे का साइड का हमको नहीं दिखता, क्यों?
क्योंकि सन की रिफ्लेक्शन नहीं हो रहा है ना सर, रिफ्लेक्शन की वजह से.
हैं?
रिफ्लेक्शन की वजह से, क्योंकि जो सन की जितनी भी रेज आ रही है उसकी वजह से हम पिछला वाला पार्ट नहीं देख सकते.
नहीं नहीं. Anybody? Any kids? Why we see only one face or one hemisphere of the moon from Earth? So?
It only faces the Earth and revolves around the Earth every 28 days.
And?
On its axis, it's also revolve around 28 days.
Correct. So rotation period and revolution period. Spinning on its axis and going around the Earth, both are same. If both are same, you will see only one side always. So it's called tidally locking, as he's telling. So it's tidally locked, so one side will be seen from Earth. कैसे भी देखोगे आपको always एक ही side दिखेगा, है ना? हमेशा. तो it becomes technically challenging when you go to the polar regions compared to that in the equatorial.
Thank you, sir.
Yeah, thank you for the nice talk. So actually, it's very basic question. I'm just, for the Chandrayaan-2, the rover and this lander is still working. Is it? They are collecting the data or?
Chandrayaan-3.
Yeah, Chandrayaan-3, sir.
Yeah. So mission was only for one lunar day, that is 14 Earth day.
Okay.
Once the night comes on the landing site, there's no sunlight, power is gone. So you can't survive the very cold conditions of the moon because temperature goes down to almost like 50 or 100 Kelvin. On the day side, it will be 400 Kelvin. So you can't survive, electrons cannot survive. It was known. So that's why we made the mission to last only for one lunar day.
Okay, so like you are planning for the Chandrayaan 5 for 100 days, so how you will incorporate, because you are also looking for the darker side of the moon.
Right, so
what are the plans?
Let me see if this one goes back. Yeah. So if you look at this site, which is 89.44 degrees, it is absolutely South Pole, right?
Yes.
So now there are locations at the South Pole also which are completely sunlit for 6 months because there's something like hills, small hills. So you assume a ball, in the ball exactly at the South Pole there is a hill and that will continuously see the sun for about 4, 5 or 6 months. There are some places where even 8 months sunlight is always seen. Okay. So those locations is chosen and that's why you see this study which was done to find out where we should actually land. It has to be smooth. It's a very narrow strip. So it's something like an aeroplane landing at a very narrow strip. But then it has to see the sunlight also. Both the rover, which has to go inside the craters, deep permanent shadow craters, and the lander should see the sunlight for its survival.
Okay. Thank you.
Good evening, sir.
Good evening.
My question is, why every time our satellite make round our Earth and then our moon, is there any cost cutting or science behind it?
Yes, this is called optimization of resources. I will go back to, I don't know whether it can come fast. It is quite back. Yeah, you're talking about this, right? So why we are going around the Earth, We don't want to go in one shot from Earth to Moon. Many missions from different agencies are doing it. They straight away launch and go to Moon. But they need a lot of fuel to do that. Because you are working against gravity when you're going up, right? So you need a lot of fuel. But then straight away, sling shot to Moon is still large amount of fuel is required. When we are doing this way, what we are doing, we are saving the fuel. Why? Because we are making this elliptical orbit more and more elliptical by giving a small push when we are very close to the Earth. So it is something like at the periapsis, we give a small push, it goes to elliptical orbit, comes back, give a small push, it goes to further elliptical orbit, comes back, push, still longer. So we are trying to increase this apoapsis to the lunar orbit. So next time when you do, it will go and come very close to the moon. There you get inserted. So it is called optimization of the orbit. You take little more time to do that, but then you save a lot of fuel actually. Sorry?
This is the cost cutting, not science.
There is no science here because we are not interested to do science in this, but there is a lot of cost cutting in terms of utilizing optimally the resources, because we want to keep the fuel for moon, not around the Earth.
Thank you.
Either.
Okay. Hello.
Yeah.
Sir, actually I have two questions. Number one, for future Chandrayaan mission, is India planning to do some particle detection like experiments on moon, because since it has no atmosphere, that is, so the particle, the probability of it getting particle is more there. So is India also planning to set up some kind of like experiments there so that we can get more knowledge about the cosmic rays and what are things happening?
And second?
Second is this future missions is India is going to include the industries, like the private sectors, to give them some intensive incentive to build more things, like set up industries around it, so it can help them like build detector technology or something like that. So
what is your background?
Since I'm currently doing masters in physics.
Master in physics, okay. So the first thing is detectors on the lunar surface or around it. Yes, these are called radiation dose monitors. Essentially that you try to measure what kind of doses will be present when we are going to the moon. So these are part of most of the missions which we do generally, and it has to be done regularly because you need to know what kind of doses the moon is getting. Cosmic ray measurements, they are being done at the Earth, around the Earth also. Whether they do on the Earth or the moon, it is more or less same. So more important is that what is falling on the lunar surface, which is not happening in the case of Earth because of the dense atmosphere. So there is a huge difference between the two. The second thing is about the private players or private entities. When we are talking about missions, already any kind of missions, there are a lot of private players which are taking part, including commercial companies. Almost like 80% of the activities is done in the private sectors currently. Okay? So many people think that only ISRO is doing that. No. There are huge companies like L&T, Godrej. They are making cases of the rockets for us, right? But they do it based on our plans, on our designs, at our own testings, because we don't need failures. So it has to go to controlled manufacturing, which is required. But they do for us. There are more than 500 companies earlier. Now there are more than 300 startups which has come in the space sector, right? And many of them are actually developing rockets and satellites of their own. So probably in the future you will see rockets being flown from private players, private industries, rather than from ISRO, right? And that is going to happen on the moon also. We are seeing private players going to the moon, private companies putting their spacecraft to go to the moon, right? Yeah.
Thank you so much, sir, for the insightful talk. As you have pointed out that we have shown extraordinary efficiency in our lunar missions and also Mangalyaan. Sir, I have just one question from you. What has been the limitation for us that we have not been exploring other planets and other celestial objects? other countries like like USA and European Space Agency, they have been actively exploring many other planets and other moons. And very little of that has been communicated to us in terms of ISRO missions. So what has been the exact limitation to that, sir?
Okay, I think my talk here was confined to Moon, but we are already on the job for Venus mission. It has been announced by the government of India already that India is going to the Venus. It will be an orbiter and probably a probe going through the atmosphere. India has already done the Mars mission. We are talking about the second Mars mission, which will be a lander mission, actually. And we are also already having a mission to study the sun in the form of Aditya L1, which is at L1 point. There are two limitations which comes when we talk about exploring the outer part of the solar system, like, for example, going to Jupiter or Saturn. First is we need a still heavier rocket, because the satellite which are going to take to these distances has to be much larger, number one. And number two, if we are going with the current technology of solar panels alone, then they have to be much larger in sizes. So you need a larger heat shield. You know, the top, you saw that in one of those, heat shield will be closed and then only it will be launched, because when you're going through the atmosphere, there's so much drag and heating, the satellite may get burned. So that's why they close it through a heat shield. That fairy has to be much larger. That means, again, the lift-off mass will increase. Means you need heavier lift-off vehicles. But this has been there. We are now currently working on heavier lift-off vehicles. So parallelly, the other track for launch vehicle and satellites are going in parallel in addition to the science missions. And once that is realized, we'll be talking about mission to Jupiter and Saturn. Because we are still not thinking of carrying thermonuclear reactors to go to this kind of missions. But in case it is required in the future, probably we'll be able to do that also.
So it's more of a technological issue?
It's more like a technological in some sense, because we don't have a heavier lift-off vehicle. And one more thing which is also there is that when you're talking about such missions, the time period is very large. If you're talking about a mission to Jupiter, it may be 6 to 7 years before you actually reach there. For example, ESA JUICE mission, it is 10 years. Launched, for 10 years you keep waiting. The mission will be reaching, right? And then only your science will start. So gestation period is very large. So that means you have to plan it well in advance for it to really get executed at that point of time. And then you need a sufficient power for doing the entire thing which you're talking about.
Are we also limited by the funding that we get?
Funding is not much of an issue. It is technological challenges which comes. Because when you're going to Jupiter, it is radiation hardened, or radiation, what I should say. It's a planet which has very harsh radiation environment. So you cannot sustain with kind of radiation tolerance which you are building in our electronics now for a mission to Moon, Mars, or Venus. No. It is extremely, extremely dangerous there. So you have to make all your electronics extremely radiation hardened, because Jupiter is a huge planet with a huge magnetosphere, right? So there are a lot of other challenges which comes when you talk about this kind of missions. But don't worry, things will happen as we progress. So be optimistic.
Thank you, sir.
Thank you, sir. Thank you, everyone. Next, as a token of our sincere appreciation, we would like to felicitate our esteemed Chief Guest, Professor Anil Bhardwaj. May I request Professor Raghunath Sahu, sir, to kindly present a memento on behalf of the Institute as a token of appreciation.
So those who have asked questions, I have something for you. Collect from me. Only those who ask questions. Those who did not, sorry. Great. Thank you so much.
Excellent lecture.
Thank you.
Next, I invite Dr. Saurabh Das, sir, to present vote of thanks.
Good evening, everyone. So I express my sincere thanks first all of the participants, all of the students come at around 5 in the evening. So I thankful that you came. I also express my sincere thanks to Professor Bhardwaj for this wonderful talk. I believe that everyone learned something new, something exciting about the Indian moon, not only moon mission, but what is going to happen in the future about that. I also thanks all the organizers, the institute for taking care of this institute outreach program, management team, the hall management, the volunteers, the staffs, and also the security, finance department, Department of IIT Indore for this talk. Thank you everyone.
So just a moment, since our Indore many school kids and teachers are there. Just for information, so this VIMARSH is essentially always a public lecture, and we try to reach all the schools. In fact, we write to all the schools, and I am 100% sure, including the students and teachers, you might have enjoyed the talk today. And we try to cover various domains of science and technology. So anytime you are getting information from IIT Indore, there is a VIMARSH talk, convince your teachers or principals, so make a visit at least. And I am sure beyond your curriculum, so you will get huge exposure. And do come to IIT Indore. So, our social responsibility is also to empower the neighbors. So in that way, you are always welcome. Okay, thank you. We have arranged a packet for all of you. So please, let's go to the assembly area, and that will give you a platform to interact with Professor Bhardwaj as well. Okay, thank you.